Right. Morning, Kamil. I'm not. Selamat Hari Raya, Kamil. Okay, so dengar tak, Kamil?
Dengar doktor, dengar.
Alright. So saya tak pastilah yang lain akan datang ke tak, tapi it's okay. I will just start the lecture. So later kalau dia orang datang, they will join the class lah, and I will also do the recording of this class. Right. So let me share my screen. Okay, so the previous week we have missed several classes. So in that classes I basically already left the video for chapter 4. So do check on the VLE and also on the Teams channel. I've already included the YouTube link to the video for lecture and also tutorial chapter 4. So means saya dah tak cover lah chapter 4. Saya dah cover lah, means I cover in the video for the lecture chapter 4 and also tutorial chapter 4. So today I will do lecture chapter 5. So we have to rush a little bit sebab we have still 4 more chapters. Kita baru halfway. But the other 4 more chapters are not that difficult anymore. Just that chapter 4 is the one that a little bit challenging. Okay, so today we will cover chapter 5, right? So chapter 5 is actually not a difficult chapter because basically chapter 5 is understanding how do we actually obtain the kinetic parameters that we have used previously in chapter 1, chapter 2, chapter 3 and chapter 4, because for the first 4 chapters we learn about rate law. Okay, so in the rate law, when we want to design reactors, we have to learn the rate law. So in the rate law, we have 2 important information, which is K, the reaction rate constant, which you have already learned, you are very familiar. And second is the reaction order. Okay, so meaning when you do rate law, when you want to design reactor, you know rate law, you have to first know K, reaction rate constant, and also reaction order. Okay, so let's say we name it as alpha. Okay, so from chapter 1 to chapter 4, we already assume that these 2 values is already known. Meaning, if katakan we want to design a reactor, we assume we already have this information either from literature or from other studies. So basically, if your reaction is common reaction, meaning reaction yang selalu has been discovered, reaction that has always been applied, most of the time you may able to obtain the values from literature, okay, ataupun daripada other studies. However, let's say if you have a new reaction, okay, so what's the definition of new reaction? As long as, let's say you change the reactant, or as simple as you use catalyst, or for example, you change the catalyst pun, this information means the value of K, the reaction order may change ataupun boleh berubah sebab reaction, that's the main complication with reaction. If you change even one parameter, okay, let's say catalyst ke, or you change reactant ke, this K and alpha will or may change. Okay, so it means that if you want to design the reactor or you want to calculate something in relation to the reactor, the value, if you use the original K, the original alpha, it may not be valid anymore. Means pengiraan tu mungkin jadi tak betul because the change of, like you said, the change of K, the change of reaction order. Okay, so there comes the next question. So what are we going to do? How are we going to find this K? You're going to find this alpha. So katakan sekarang ada tindak balas baru. Okay, you have to find, or you want to verify whether the K or alpha, the reaction order is the same or it changed. Okay, so that's the purpose of chapter 5. We will learn how are we able to determine these 2 parameters through experimental work. So imagine now you're in the lab, okay, you have different type of reaction, new type of reaction, or you just want to verify the value of K, the value of alpha. Okay, so you will run the experiment in the laboratory. So from the experimental result, you will then use to calculate K and calculate alpha. Okay, so but Okay, kenapa we need until one whole chapter to learn this? Because it sounds easy, right? It's just experimental work. This is because they got different method. Okay, so you may run the experimental work, but to calculate the value of K and the reaction order, you have different methods. So you're going to learn 4 different methods, of which we will focus on mainly 3 methods which are commonly used. Okay, and then to run this experiment, okay, katakan sekarang you want to run experiment to determine K and alpha, you will usually do it in a batch reactor. Okay, so whenever we want to establish kinetic parameters, preliminary reaction, we will always run in a batch reactor because the system, the configurations are simple and you can run it straightforward. So, kalau you buat dalam flow reactor, the thing can be quite complex. So, usually kalau kita nak run to just determine kinetic parameters ni, kita akan guna batch reactor. Okay. Then, next, what kind of information that you will get or you will have to collect from the experiment. Okay, what kind of data that you are collecting from the experiment depending on the method. Certain method you measure concentration with time. Meaning you imagine, okay, I run experiment, I prepare my fresh solution, I know the concentration. Let's say I prepare reactant A, concentration dia let's say 5 molar. Okay, then I place it in the batch reactor, okay, and then let's say every 5 minutes, okay, I will take out my sample, I check the concentration, okay, so every 5 minutes I do that, I check concentration, so I will get a series of concentration data with time. And then logically, memanglah the concentration must decrease with time because your A will be consumed during the reaction. Meaning with time, okay, let's say you start with 5 molar, at the 5th minute, of course, it's lesser than 5 molar. So let's say 5 molar, 4.5 molar at 5 minutes, 4 molar at 10 minutes, 3.5 molar at 15 minutes, so on and so forth. So you collect that data, then you will then use the method of calculation. You can determine K, you can determine alpha. Another method is using half-life method. Okay, kalau half-life method, the data that you collect are already different. It's no longer concentration versus time, which we will learn later when we learn the half-life method. Okay, so regardless what method that you learn, okay, you learn, I told you 3 methods. Regardless what method you learn, it's still the same thing that you want to obtain information, which is reaction order, and also alpha and reaction rate constant K. So method apa kita guna pun tak apa, kita masih just nak tahu alpha, reaction order and reaction rate constant K. Okay, so the methods are as following. Okay, we have differential method, integral method, half-life method, and initial rate method. Okay, the one that we're going to learn deeper is differential method, integral method, and half-life method. Okay, so we're going to explain one by one what we're going to have. Okay, what you're going to collect information from the experiment and how we use the information to find K, to find alpha. Okay, so we start first with half-life method. Okay, so the word half-life means information that you collect must be related to half-life. But first of all, you have to understand apa tu half-life. Okay, so half-life, we use the denotion or the symbol T subscript 1/2. T half lah basically. Okay, so apa tu T half? T half is basically time needed for your initial concentration to become half of its original value. Okay, maksudnya, let's say, okay, in first run, you prepare a solution. Let's say you prepare 5 molar of reactant A. Okay, so you put in the reactor, right? So you let's say in this case, every 1 minute, you will take out sample, you will check the concentration of A. Okay, so you will keep checking until it reach a time of which concentration tu jadi separuh daripada concentration asal dia. So means from 5 molar, how long it takes for it to become 2.5 molar. So the time needed for it to become half of its original concentration, we call it as T half. Okay, so run pertama 5 molar, saya tunggu sampai berapa lama dia jadi 2.5 molar, that will be my T half. Okay, so this method, dia punya cons, the weaknesses, not weaknesses, the cons of this method, you have to redo a few series of experiment because each time you run one run, you can only prepare one fresh solution. So means katakan run pertama dah prepare pada 5 molar, okay, catat berapa masa dia jadi 2.5 molar, that's run 1. So you have to do another run, the second run, okay, you have to, tadi run pertama you dah clear the reactor. The second run, you prepare at different initial concentration. Let's say 8 molar. Okay, so jadi 8 molar. Again, you put into the reactor, you let the reaction occurs, you record how long it takes for it to become from 8 molar to 4 molar. Okay, so second run, habis. Okay, catat masa dia. So again, start. Remove the reactant from the reactor, remove it from second run. Do the third run. So third run pula, kena prepare pula another fresh solution of a different concentration. Okay, so you have to keep repeating doing it until, let's say, it depends how many set of data that you want to obtain. Okay, so for example, in this table, we assume we run 6 different runs. And of these 6 different runs, all of them have different initial concentration ataupun different fresh solution. Then you catat the masa, you record the T half, and from this table of information, we want to determine K and alpha. Okay, so of course, when you look at the table, it doesn't make sense sebab data dalam table tu tak ada apa-apa pun berkaitan dengan K, tak ada berkaitan dengan alpha. So meaning, we have to find a correlation first. How do we correlate data experiment dengan what that we want to find, K and alpha. Okay, so we are very fortunate. There is already an equation given ataupun there's someone who has already found a correlation between T half, alpha dan K. So this equation is given as T half equals to 2 power alpha minus 1. Alpha is our reaction order. So kita dah belajar kan zero order, first order, second order. Tapi sekarang kita tak tahu yet. We don't know yet what order of the reaction. Okay, then minus 1 per K in bracket alpha minus 1 in bracket 1 per Ca naught alpha minus 1. Okay, so now if you realize in that equation, dia ada correlation yang penting. Dia ada correlation between T half, Ca naught. Sebab dalam data eksperimen kita kan T half dengan Ca naught. Dan juga ada kaitan, we already correlate with alpha and K. So this equation has already given the correlation. Tetapi sekarang, the issue is how do we use this equation pula? Dah ada correlation, tetapi macam mana kita nak convert experimental data itu untuk in the form of which we can find alpha, we can find K. So to do this is what we do is we have to first, linearize the equation. So kenapa kita nak linearize equation ni ialah kerana if we can linearize the original equation and we get it in the form of y equals to mx plus c. So if you remember, kalau kita nak plot graph, kalau kita nak plot satu graph dengan garis linear ataupun we call it as linear line, straight line, the equation of which kita nak plot graph tu mesti dalam bentuk y equals to mx plus c. Maksudnya kalau equation originally just now, I can linearize in the form of y equals to mx plus c. I can actually plot a graph based on my experimental data. Saya convert dalam bentuk linear equation, saya boleh plot a graph, and from the graph, hopefully we can get K, we can get alpha. So tapi tak boleh sebarangan linearize. So to linearize this equation, the one that I'm pointing right now, what we do is you will take natural log ataupun natural logarithm on the left and on the right. Kita lonkan belah kiri, kita lonkan belah kanan. Why we do this again? Sebab kita nak linearizekan equation tu ataupun arti kata lain, kita nak equation tu dalam bentuk y equals to mx plus c. So When you do natural logarithm on both sides, eventually you will get on your left hand side ln t half. Okay, so this is a bit of mathematics lah. How it becomes the linearized equation tak penting. Maksud saya bukan tak penting lah. Maksudnya yang penting macam mana kita nak gunakan equation yang linear itu. Okay. So on the right hand side, so the front part it will become ln 2 power alpha minus 1 per k alpha minus 1, and the back part, the second part of the equation, if you remember, when you have two different variables multiplying one another, bila you ln-kan, multiplication tu jadi tambahan ataupun jadi addition. Okay, so when you have two variables, in this case you can see the first variable multiplying the second variable. So bila kamu ln-kan, what happens? Yang multiplication tu jadi addition. That's why it become plus. And then the next one, the alpha minus 1, power yang kat bawah tu, okay, when you ln-kan, it become in bracket 1 minus alpha ln CA0. So kenapa 1 minus alpha walaupun originally dia adalah alpha minus 1 sebab this is 1 per CA0, alpha minus 1. So kalau kita naikkan by right, kita akan dapat CA0 1 minus alpha. So bila CA0 1 minus alpha, kita ln-kan, yang kuasa tu pergi ke hadapan. That's why you get 1 minus alpha ln CA0. Okay, but however, it's okay if, because this is a theory of mathematics, yang penting untuk kita ialah kita dapat dalam bentuk the linear equation first. Okay, so we have to rearrange. Okay, so bila kita rearrange, left hand side, okay, masih ln t half. Okay, on the right hand side, you see that I jumble out. I bring the back to the front to the back. So you see now, become equals 1 minus alpha ln CA0 plus ln 2 alpha minus 1 per k alpha minus 1. Okay, so why do I do this? Why I switch? Yang tadi yang kat belakang ln CA0 tu 1 minus alpha ln CA0, kenapa saya buat depan? Kenapa yang satu itu saya buat belakang? Okay, so ingat again. Kenapa kita nak cari linear equation ni? Sebab from experimental data, kita nak dapatkan K dengan alpha. Dengan harapan when we linearize the equation, dalam bentuk Y equals to mx plus C, I can plot a graph. I want to find K and alpha. Okay, so kita tahu bila kita nak plot graph, okay, kita nak plot graph, kita kena ada the point. Okay, so yang point-point dalam graph tu sebab kita kena ada point, baru kita can draw a straight line. Okay, point-point ni kita tahu untuk setiap point dalam graph kita, point tu memerlukan data paksi Y, data paksi X. Maksudnya, the point, to plot the point, the data must be what we already have. And the data must be in the form of Y-axis and data X-axis. Setiap point tu kena ada data paksi Y, data paksi X. Okay, so kenapa saya, why the equation become in this form is because I have to already fit data apa yang saya ada untuk menjadi data paksi Y dan juga apa lagi data yang saya ada untuk menjadi data paksi X. Okay. So experimental data that I have is T half CA0. Ni saya buat eksperimen, saya data CA0, saya ada data T half. So you can see from this equation, the ln T half tu boleh menjadi data paksi Y saya. So meaning data eksperimen saya T half, right? Tapi kalau saya ln-kan T half itu, saya dah dapat data untuk paksi Y. Means point saya tu, saya dah tahu dah untuk data paksi Y dia. Okay, so that I go to the right hand side. You can see the only thing yang boleh menjadi data paksi X saya will be ln CA0 because experimental data saya CA0 sebab saya ada data setiap CA0 saya tahu T half dia. Setiap run I change my CA0, I get different T half. So the CA0, if I ln-kan the CA0, I will get the data for my X axis. So now I re-establish experimental data. If I ln-kan, I can plot the point, I can draw a straight line. Okay. So sekarang saya dah establish, saya dah boleh buat tu. Okay, tapi apa yang kita nak? Kita nak K, kita nak alpha. Itu yang kita nak cari daripada plot. So kita tengok balik persamaan ni. So you can see, okay, kalau the equation in the form of Y equals to mx plus C, if you forget, M is your gradient or your slope of the graph. C is your y-intercept. Means kalau you plot graph, okay, kecurunan tu adalah M. C tu adalah pintasan Y, line the mana where the line intersects the Y-axis, that will be your Y-intercept ataupun we call it as C. So naturally you can see that the 1 minus alpha is equal to the gradient of your graph. So imagine kamu ada data part CY, data part CX, saya plot graph, saya buat straight line, saya measure dia punya saya measure dia punya slope or gradient. Okay, kalau you use software, you use Excel, it's automatically they will do for you. So the gradient is equal to 1 minus alpha. So naturally kita dapatlah alpha sebab kita dah tahu nilai gradient daripada graph, kita dapat alpha. So we solve already one. We already get alpha from the graph reaction order. Next one, what about K? So from the equation you can see the back part, yang panjang-panjang ln to power alpha minus 1 per K alpha minus 1. This entire thing is our y-intercept. So kita plot graph, kita tengok mana graph tu memintas pada part CY, that point. Nilai tu bersamaanlah dengan ln 2 alpha minus 1 per K alpha minus 1. So since we already know alpha from the gradient, so we are left only with K, hence we can get the value of K. Okay, so that's how we use experimental data. We use the equation in the form of a linear. We plot a graph. From the graph, we will determine these two values. Okay, so how does this simplify back in the form yang tadi saya cerita tu, macam mana kita tengok balik bentuk dia. Okay, so imagine from the very first stage, you will run the experiment. So katakan kamu run dalam eksperimen ni 6 run. Okay, setiap run, I use different initial concentration. I record the time, how long it takes to become half of the initial concentration. So run pertama daripada 5 molar kepada 2.5 molar, how long? Second run, let's say from 8 molar to 4 molar, berapa lama? Third run, 6 to 3, let's say, berapa lama, so on and so forth. So daripada run tu, what I do, I get the experimental data. Sebab equation saya memerlukan data dalam bentuk ln T half, ln CA0. So I lnkan my experimental data. So CA0 katakan tadi 5 molar jadi ln 5. Katakan T half dia 10 minit, so ln 10 minit, ln 10. So let's say the second run, CA0 dia let's say 8 molar, so I lnkan 8. Let's say T half masa diperlukan adalah 20 minit, so ln 20 for the T half. So I got now the experimental data. I already got the data for the graph. Okay, so dalam set ni katakan kita ada 6 point lah, kita ada 6 data, kita ada 6 point. So 6 point ni you will plot the graph. Kamu tahu kan setiap point ni memerlukan data part CX, data part CY. So you will plot. So imagine patutnya kena ada 6 point lah. Tapi graph contoh saya ni ada 4 point, tak cukup lagi 2 point. So imagine you have this point. Okay, then you definitely will get a straight line. Dia mesti akan straight line. So you just draw a straight line to connect all the points. Okay, so if you're using Excel, this is very simple. Okay, so not manual, you use Excel. Excel will automatically do this for you. So you dapatkan data part CY, data part CX. You ask Excel to draw a linear plot for you. They will come up with a plot. And even better, Excel will calculate for you immediately. What is the gradient? What is the y-intercept? Nilai di mana dia memintas pada part CY. So from these two data, you will get K, you get alpha. So to repeat, so maka from the equation, gradient equals to 1 minus alpha. So 1 minus alpha equals to gradient. So you get your alpha. Okay, then the value of alpha, reaction order. So I taught you, reaction order tu kan dia mesti integer ataupun angka bulat. Zero order, first order, second order, so on and so forth. So let's say if you get the value in the form of fraction, katakan you get 1.1. So you have to round up to the nearest integer. So kalau 1.1 nearest integer 1 means dia adalah first order. Let's say you calculate alpha 1.8, round up second order sebab dekat dengan second. You get 0.8, round up jadi first order. If you get 1.4, round up jadi first order. So meaning you have to always round up to the nearest integer. Okay. Then next, to find K. So from the y-intercept value that Excel has already calculated for you, right? And then you know your alpha, hence you can use the equation. So y-intercept equals to ln 2 power alpha minus 1 per k alpha minus 1. Right, okay, so then you will get your value k. Right, so let's say we try a very quick example sebab half-life method ni tak susah. Method yang susah lagi dua method tu, lagi method yang another two method is a bit hard. Half-life is quite straightforward. Okay, so then imagine now in this question, all right, I do the experimental run. Okay, so I do the experimental run. Let's say here I do 6 run. Okay, so setiap 6 run tu you can see we use different initial concentration. So run pertama, I run my fresh solution of my A, reactant A tu pada 0.0250 molar. So then you run, it takes you 4.10 minute for it to become half of its original value. So run kedua, I prepare new one 0.0133. Run ketiga 0.01. Okay, so run, I get my half-life. Okay, so data eksperimen ni, you imagine now, saya nak cari K, saya nak cari alpha. Okay, so first step, okay, always remember, cari dulu equation dia sebab kamu kena tahu daripada equation tu dulu. Then you will remember apa data yang saya perlu untuk part CY, data yang saya perlu untuk part CX. So daripada equation half-life, okay, kalau dia beri data eksperimen half-life, mestilah menggunakan half-life method. Okay, so kamu tengok daripada persamaan from the equation, you know, ln T half is my y-axis data. Data part CX ln CA0. So first step, convert lah dulu ataupun carilah dulu the data for part CY for the y-axis and the x-axis. So contohnya CA0 0.0250, but my x-axis data must be ln CA0. So saya lnkan 0.0250. So I get negative 3.69. So you just press calculator, lnkan dia, dapat nilai dia. Okay, then T-half. T-half pertama 4.10 minit. So walaupun data eksperimen T-half, but untuk plot the graph, my data must be, my y-axis data mesti dalam bentuk ln T-half. So saya lnkan 4.10. So I get 1.41. So I repeatedly doing it until I finish the entire set of experimental data. So data yang dalam kotak kuning ni, kita guna untuk plot graph. So you know kan Excel, once you get this data, you plot a graph, dia automatically akan convert experimental data ni dalam bentuk plot. So you imagine, this is the plot that we obtain from Excel. Okay, so dulu kalau those yang physical exam, dia kena buat manually, dia kena prepare, dia kena buat kertas graph, dia kena plot. So for you guys a bit lucky, because your exams are non-physical, non-face-to-face, you may use Excel. Yang penting kena tahulah cara nak guna Excel. So from Excel, when you plot the graph, macam sekarang ni saya kira manually. Saya tunjuk jalan contoh penyiraan manually. Tapi sebenarnya kalau guna Excel, you know, Excel automatic terus bagi dia punya gradient. Okay, so the gradient, if you use Excel, the gradient you will get actually negative 1. Kita boleh tengoklah kecurian dia memang kecurian negatif. Dia punya line tu, line dia adalah condong tu ke arah negatif. So Excel give that the gradient is negative 1. So kamu kena ingat, gradient dia negative 1. Alpha dia bukan negative 1 sebab daripada equation, gradient M tu equal to 1 minus alpha. Means 1 minus alpha equals to negative 1. Then only you get your alpha. So your alpha is actually 2, or we can say second order. So apa maksud second order? Means rate law dia akan menjadi minus RA equals to K CA power of 2. Sebab dia adalah second order with respect to A. So jadi KCA power of 2. Done. Okay. Then next, cari K. So our next target is to find K. So to find the value of K, again, look at the equation. Y-intercept is equal to the back part of the equation yang panjang-panjang tu. So maksudnya daripada graph, your y-intercept Excel will give you the value is actually a negative 2.4, the one that I'm pointing right now, this one. So it's actually negative 2.4, means the ln 2 power alpha minus 1 per k alpha minus 1 equals to your y-intercept negative 2.4. Okay, so since kita dah tahu alpha is second from the previous part, so we can solve this, you can get the value of k as 11.02. So itu adalah value your reaction rate constant. So sekarang kamu dah establish untuk eksperimen ni, untuk reaction kamu ni, okay, you get the rate law minus RA equals to KCA power of 2, and you also know the value of K as 11.02. Okay, but there's one more thing that you have to understand. The unit of K. Okay, sebab dalam case ni, bila kita buat pengiraan dalam bentuk ln K, ln T half lah, ln CA naught lah, often we have difficulty determining the unit of K. However, I have taught you in chapter 2 sebenarnya that the unit of K can be deduced from the reaction order. Okay, so saya dah ajar untuk zero order, first order, second order. Unit K tu sebenarnya dah ditetapkan. Tapi kita kena ingatlah apa perbezaan unit dia. Okay, so kalau it is zero order reaction, katakanlah kamu dapat rate law dia minus RA equals to K. Sebab CA power 0 is 1, right? So kalau zero order minus RA sama dengan K. Maka the dimension of your K will be concentration per time. Ataupun contoh unit dia mol per liter minute. So kalau reaction kamu zero order, unit K dia terus confirm dia mesti concentration per time. So bergantunglah kalau kamu guna mol per liter concentration, so jadi mol per liter time. Katakan kamu guna hour, so jadilah hour. Kalau kamu guna second, jadilah mol per liter second, so on and so forth. Okay. However, kalau dia first order, okay, the dimension of K will be 1 per time ataupun per time. So maksudnya per hour, per minute, per second, depending on the unit that you use lah. So for example dalam eksperimen ni, dalam soalan ni, data time kamu minute. So kalau dia first order, unit K tu adalah per minute. Katakanlah T half kamu hour, jadilah K kamu per hour. Okay. However, dalam case ni dia adalah second order. So kalau second order, the dimension of K is 1 per concentration time. Tekanlah concentration kamu mol per liter. So 1 per concentration time jadi liter per mol minute. Like this example. So let's say katakan you use hour. So jadilah liter per mol hour. So on and so forth. So unit of K ni memang automatik dah kena tahu ataupun dah kita faham ataupun dah ditetapkan based on the reaction order. Yang penting kita kena faham perbezaan dia. Kalau zero order, what happens to the dimension and unit? First order, second order. Okay, right. So that's for the very first method. So very first method half-life ni memang senang. Okay, so there are the pro and cons lah. Okay, so half-life method ni pengiraan nak plot graph is very easy. The cons dia adalah you kena repeat banyak eksperimen sebab untuk dapatkan data untuk plot graph takkan nak 3-4 data, it will not be accurate, right? So you have to run at least 6 or 7. So you have to repeat eksperimen banyak run just to get the value for to get the K and alpha. So itu adalah cons half-life. Eksperimen banyak tapi pengiraan senang. Okay, next method, differential method. Okay, so differential method pula, you already know the word differential. Differential meaning this will involve differential equation. We are going to use differential equation. Okay, the good about this method, differential method adalah this differential method experiment dia straightforward. I just do one experiment. Okay, so for the experiment, I will gather my data. And then I will use equation to determine K to determine alpha. Okay, so yang good thing, just one experiment, I already get the enough experimental data. I can proceed to get K and alpha. The cons is, in order to get the K and alpha from the equation, it is more complex or I say will be more tedious. Banyak benda yang kita kena kira dulu sebelum kita boleh dapat this K and alpha. Konsep dia masih sama macam half-life. I still need to plot a graph. Tapi in order untuk kita nak plot graph, tadi if you realize half-life, kita nak plot graph tu information dia senang. Kita just cari log, kita dah boleh plot graph. Differential method, you have to find a lot of things first just to get the y-axis data, x-axis data, baru kita boleh plot graph. So there are the pro and cons of differential method. However, the aim is still the same. We want to find reaction rate constant, K, and we want to find alpha, reaction order. Okay, matlamat masih sama. The main aim is still the same. The difference is experimental wise. The difference is in the method of the calculation. Okay. And also, same with differential method, same with half-life method. Dia hanya kalau kita ada satu reactant sahaja. Right, okay. Now, what do we do to run experiment or to get the data to run using differential method? So if you're using differential method, what you're going to do is, you're just going to prepare a solution of determine initial concentration that you have already predetermined. Let's say you prepare again 5 mole per liter of reactant A. So you place it in a batch reactor. We always run in batch reactor. So you decide yourself, are you going to collect the sample every 5 minutes ke, every 10 minutes ke, every 1 minute ke, every 2 minutes? It's depending on you. Okay, but again, macam mana kita nak tahu? Actually depending on the nature of reaction. Certain reaction kalau dia adalah cepat, so the gap time kamu nak record data kena pendek. Means let's say every 1 minute or 2 minutes. But if your reaction is a slow reaction, so maybe the gap time yang kamu nak ambil data tu can be every 5 minutes, can be every 10 minutes depending on you. Sebab yang penting kita nak catat berapa lama masa yang diperlukan untuk dia from yang initial concentration tu sampai dia habis consume in your reaction. So what you going to do, let's say you decide every 5 minutes. So 5 molar letak dalam reactor, minit ke-5 take out sample, check concentration A. Minit ke-10 take out another sample, check concentration of A. Minit ke-15, so on and so forth until ideally dah sampai tak ada dah kepekatan A dalam kamu punya reactor. Meaning if I got no more A in the reactor means all my A already converted into product B. So imagine, okay, so satu eksperimen run let's say 1 hour. Okay, katakan dalam 1 hour tu setiap 5 minit kita ambil sampel. Okay, then katakan dalam masa 60 minit dah habis semua A consume. So you can imagine your plot of the graph, if you plot CA versus time, concentration versus time, you will get this kind of a plot. Okay, definitely concentration will decrease with time, concentration of A, because A will be consumed. Okay, so now next. Masalah yang sama juga. Kita nak cari K, kita nak cari alpha. But we are still not able to find the correlation. So we have to find the equation or the correlation between our data, our experimental data. Kita sentiasa kena relate experimental data yang kita ada with K and alpha that I want to find. Okay. So since this is differential method, we will use differential equation. So the differential equation is given as minus dCA per dt equals to minus RA, okay, equals to KCA alpha. So I explain first how do we get this equation. Okay, so first of all, dCA per dt, sebab the differential equation, right? Okay, so dCA per dt mathematically it means differential. Okay, chemically it means we want to see the change of concentration of A with time, which is true lah sebab daripada eksperimen kan kita kaji perubahan kepekatan A with time. So the D is to signify the changes. Okay. Now, why there's a negative di hadapannya? Because we know chemically in this scenario, concentration of A must decrease with time. So if you don't put the negative sign, it doesn't imply that concentration A itu akan menurun dengan masa. Tapi kita tahu chemically dalam tindak balas ni, kepekatan A must decrease with time. That's why there's a negative in front to signify that the concentration of A must decrease with time during the reaction. Okay, so these changes of concentration of A with time is equal to our rate law, which is KCA power of alpha. K kita nak cari, kita tak tahu. Alpha reaction order kita nak cari, kita tak tahu. Okay, so now you can see somehow kita dah dapat a correlation. Sebab kan tadi saya kata kita nak correlate experimental data, CA and time, and apa yang kita nak cari, K dan alpha. So you can see from this equation, kita dah ada correlation tu. Sebab kita tahu minus dCA per dt, CA dengan T adalah apa yang saya ada, adalah equals to KCA power of alpha. K I want to find, alpha I want to find. Okay, so now dah ada correlation dia. Tetapi still the same problem macam tadi half-life method. In order for us to find these two value, you have to again find a linear form of the equation. Dan dalam linear form tu, kita kena ada, again kita nak plot graph. So kita kena ada data part CY, data part CX. Dan juga for the data of the y-axis, x-axis, this data must be something that we have. Kita yang dah ada. Maksudnya pada eksperimen punya data yang kita dah ada tu, kita nak kena plot graph. Dan plot graph tu lah kita harap kita boleh dapat alpha, kita dapat K. Because we are plotting a linear equation. So similarly like previously, what you gonna do? You will take natural ln. Ataupun kita lonkan di belah kiri, di belah kanan. Okay, again, kenapa kita buat ni? Solely sebab kita nak dapatkan persamaan dalam bentuk linear, which is in the form of y equals to mx plus c. Bila kamu dapat linearkan equation tu dalam bentuk y equals to mx plus c, you will be able to plot a straight line plot. So in order to do that, kita akan lonkan kedua-dua belah. So when you lon on your left hand side, you will get ln in bracket negative dCA per dt. On the right hand side, bila kita lonkan, so you will get, again, kamu tengok dalam case ni, kita ada dua benda. Kita ada variable K, kita ada variable CA power alpha. So basically, principally, mathematically, K tengah darab dengan CA power alpha. So bila you lonkan these two variable, yang darab, the multiplication become addition. Sebab tu kamu akan dapat dalam bentuk ln K plus kuasa tu akan turun bawah. So, jadi alpha ln CA. So, kalau kamu nampak, saya macam terbalikkan kan. Ln K saya letak kat belakang. Alpha ln CA saya letak kat depan. So, kenapa? So, again, kenapa kita buat ni? Sebab saya dah dapat sekarang in the form of y equals to mx plus c. Tapi saya kena decide what we going to be my y-axis, what is going to be my x-axis. Sebab saya perlukan data y dengan x ni untuk plot graph. So data the y-axis and x-axis must be from what I already have ataupun from my experimental data. So data eksperimen kita adalah CA dan time. So you see on the y side, on the left hand side, kita ada CA, kita ada T, kita ada time. Tetapi fortunately kita ada data tu. Tetapi kita tak boleh straight away guna data eksperimen because dalam equation, data dalam untuk y-axis mesti dalam bentuk ln in bracket minus dCA per dt. Ataupun arti kata lain, from data eksperimen tu, yang saya ada CA dengan time tu, saya kena convert dulu dalam bentuk ln in bracket minus dCA per dt. Okay, so tak apa tu kita akan belajar shortly, but at least now kita tahu this will be my y-axis data. Okay, so settle. So, pergi tengok belah kanan pula. Mana data yang boleh jadi x-axis? So, naturally, tak mungkinlah alpha, tak mungkinlah ln K sebab these two kita tak tahu yang kita nak cari. So, alpha ln K can never be my x-axis data sebab this is the two things that I want to find. So, of course then, ln CA will become my x-axis data. Okay, so daripada eksperimen tadi kita ada CA dan time, right? So, kalau saya lonkan data CA saya dah dapat data untuk pasti X. So, X-axis punya point, data tak susah. Experimental data tu, I lonkan, I dah dapat. Masalah dia adalah data part CY. Sebab data part CY ni, eksperimen kita hanya ada CA dan time. Tapi data part C1 yang kita nak perlukan is ln negatif DCA per DT. Okay, so tak apa, tu shortly while kita akan tengok macam mana kita nak buat. Okay, then come back again. Sekarang kita dah establish Y and X axis punya data for the point. So now comes, so how to get alpha to get K from the plot? So you imagine now, you plot a graph. So katakan dalam kes ni ada 6 point kan? Okay, kita ada 6 run. Setiap run tu kita boleh sebenarnya dapat satu plot kan? 1 point. So kita dah ada 6 point. Tapi 6 point tu kamu kena ingat, untuk point pertama ni kita kena tahu data part CY dia mesti ln minus DCA per DT. Data part CX dia ln CA. So kita dapat 6 point. Okay. So there you can see from the equation, the gradient is equals to your alpha. So y equals to mx plus c. So from the equation, my gradient or my slope of the plot will be my alpha reaction order. So let's say you plot a graph from Excel, Excel will give you the gradient value. The gradient value is actually equals to your reaction order. So same concept, kalau dia dalam bentuk fraction, you have to round up to the nearest integer. So katakan 1.8, round up jadi second order. 1.4, round up jadi first order. 0.8, round up jadi first order. 0.4, round up jadi zero order. So you must always remember, kalau this is a real application, dia tak semestinya limited kepada zero order, first order, second order. Dia boleh jadi third order, fourth order. Although, very rarely lah. Sebab biasanya mechanism tindak balas, it will only be about zero order, first order, second order, the common ones. Okay, so kalau dalam exam ke apa pun, I will make sure lah it's between this order of reaction. Okay, then next, what about K? So from the equation, you can see yang bahagian belakang tu adalah equals to C kan? So C is your y-intercept, meaning your y-intercept sama dengan ln K. So katakan you get your y-intercept daripada Excel, katakan your y-intercept adalah 5. So ln K sama dengan 5, therefore K sama dengan exponential 5. So katakan ln K sama dengan nombor, nak tahu K, nombor tu kamu kena exponentkan. So then now you can get your K, you can get your alpha. When you plot the correct graph, you draw the straight line and you determine the gradient and the y-intercept. However, the problem with this method, as I told you, adalah sebab ln minus DCA per DT tu. Sebab again, data eksperimen yang kita ada, kamu bayangkan eksperimental data yang kita ada adalah ini. At every minute zero, concentration CA0 saya, katakan 5 molar. Okay. So, katakan minit kelima, berapa CA1 saya? Katakan 3 molar. Time ke T2, katakan 10 minit. CA2 saya katakan tinggal 2 molar. Katakan at 15 minutes, my concentration become 1 molar. Itu je data yang saya ada eksperimen. Tetapi, saya tak boleh straight away plot the graph untuk cari alpha dengan K. Sebab kalau saya nak guna differential method, saya kena dapatkan dulu data paksi Y in the form of ln minus DCA per DT. Data paksi X, not a problem. Okay, data paksi X senang sebab data paksi X kita lnkan saja. So, data paksi X kita kan ln CA. So, kamu bayangkan kamu lnkanlah CA0, lnkan CA1, lnkan CA2, lnkan CA3. Dah dapat dah data paksi X. Tapi masalahnya, setiap point itu memerlukan data kedua-dua paksi. Paksi Y, paksi X. So, now, how do we get the data for ln minus DCA per DT. So this slide is to show, okay, katakan saya ada 4 run. 4 run tu saya ada kan, not 4 run, I got 4 set of data. I know my CA, not CA1, CA2, CA3. Saya lnkan, saya dah dapat dah satu kolom data paksi X, which is ln CA. Okay. For data paksi Y, ln minus DCA per DT, that becomes the problem. How are we going to obtain or calculate that data? Okay, they are actually different methods. So, bayangkan nak dapatkan ln minus DCA per DT ni pun sebenarnya ada method yang berlainan. Tetapi, we will use the most simple or the most straightforward one, which is what we call as numerical differentiation formula, ataupun in a very simple way to say, kita guna formula, kita kira untuk kira ln minus dCA per dt. Tetapi remember I told you this method is menyusahkan sebab formula dia pun menyusahkan. One. Second, formula ni pun tak straight away cari ln minus dCA per dt. Formula ni hanya untuk mencari, or the formula only will solve until you get dCA per dt sahaja. Means kalau kita guna formula ni, kita hanya dapat kira sampai dCA per dt. Tetapi jangan lupa, don't forget, graf saya memerlukan ln minus dCA per dt. Means daripada formula yang kamu kira, you have to negatifkan the value and then subsequently you lnkan the value. So for example, let's say you get dCA per dt from the formula as 5. So kamu kena negatifkan nilai dia, negative 5, and then kamu lnkan nilai dia, ln negative 5. Barulah kamu dapat ln minus dCA per dt. Okay, so most of the time method ni, that's the mistake that we normally do. Kita lupa yang formula tu hanya cari dCA per dt. Tetapi to plot the graph, it must be ln negative dCA per dt. Okay, so kadang-kadang you might calculate the dCA per dt dapat negatif. Katakan dCA per dt tu negatif. So, tapi kita nak cari ln minus ataupun ln negatif dCA per dt. So, kamu kena negatifkan nombor tu. So, kalau negatif 5, you have to negatifkan it once more. So, become positive lah kan? Because negatif is positive. So, you have to lnkan 5. Okay, you cannot lnkan negatif 5 sebab negatif 5 tu dCA per dt. Kalau dia nak negatif dCA per dt, negative 5 become positive 5. You lnkan the positive 5, then only you get the ln minus dCA per dt. Okay, that's one. Tu yang confusion yang biasa berlaku. Second confusion, formula ni pula bukan satu formula sahaja. Sebab tu nama formulas. Multiple. Sebab dia ada formula yang berlainan. Why? Because it depends on which dCA per dt yang kamu tengah cari ataupun kamu tengah kira. Okay, what do I mean by that? Okay, let's say in your experiment, in your run, you run, kamu ambil 4 kali data. Means, okay, minit 0, CA0 5, minit ke-5, CA0 3. Minit ke-10, CA0 2, minit ke-15, CA0 1. So, means kamu ada 4 set of data, right? Kamu ada 4 set of data. Okay. Nak kira dCA per dt untuk data ni bergantung kepada susunan data mana yang kamu nak kira. Okay. If you are calculating the very first dCA per dt ataupun kamu mengira dCA per dt untuk masa kosong, kamu akan menggunakan formula, kita call it as initial point formula. So even from the word pun dah tahu kan initial point kan. So hanya untuk mengira the very first dCA per dt dalam set data kamu, you use the initial point formula. I will show you later. Then ada lagi satu lagi formula. The next formula, any point ataupun any reading in between the very first reading and the very last reading, kamu akan menggunakan formula yang sama. We call it interior point formula. Maksudnya dalam kes ni, kamu ada 4 data, 4 bacaan, right? Okay, bacaan kedua dan ketiga, you will use interior point formula. So, katakan kamu ada 6 bacaan. So, maksudnya bacaan pertama kamu guna initial point. Bacaan kedua, ketiga, keempat, kelima. 4 bacaan itu bila kamu nak kira dCA per dt dia, you will use interior point formula. Formula yang berlainan. Okay, sebab tu saya kata method ni a bit tedious. Dah ada formula. Formula pula berlainan. Dan formula tu pula tak cari directly, dia baru cari dCA per dt. So kamu kena ingat pula, dapat DCA per dt, saya kena cari pula ln minus DCA per dt. So this is the tediness about the word. However, you just remember, in a real application, you're using software, using Excel, you can key in the formula, automatically it can be calculated very easily for you. Okay, and the last one, if you are finding you're finding dCA per dt for the very last point ataupun for the very last reading, you will use last point formula. So contoh dalam kes ni, when you have 4 bacaan, you have 1 initial point, 2 interior point, 1 last point. If you have 6 reading, 1 initial point, 4 interior point and 1 last point. So akan menggunakan formula yang berlainan. Okay. So I will start first with initial point punya formula. Okay. So memang kalau tengok formula dia jadi macam pening sebab formula tu macam a bit confusing. Okay, but I will teach you the easiest way nak mengira sebenarnya. Okay, nah, so imagine kita ada 4 data, 4 bacaan. Kita ada 4 bacaan eksperimen. Kami ingat eksperimental data kamu ada 4 bacaan ni. Katakan minit 0, minit 5, minit 10, minit 15. Katakan 5 molar, 3 molar, 2 molar, 1 molar. Saya nak cari dCA per dt untuk bacaan yang pertama. Bacaan yang pertama sahaja sebab saya nak guna initial point. So, to find that dCA per dt in the yellow box, the formula is given. You can see here, dCA per dt at T0, T0 kan? Okay, sebab initial point, dia sama dengan minus 3 CA0 plus 4 CA1 minus CA2 per 2 delta T. Okay, so kamu kena ingat, formula ni memang dah diberi. Okay, itu untuk mencari dCA per dt untuk point yang pertama. Okay, so always yang student get confused, which I can understand, apa tu CA0, CA1, CA2. Okay, kamu just remember, kamu ambil or you take the first 3 concentration dalam bacaan table kamu. So dia akan menjadi minus 3 multiply with the first CA0, katakan 5, plus 4 multiply with the second CA ataupun CA1. So katakan 3, so plus 4 multiply with 3 minus CA2. So katakan 1, so minus 1. So kamu just ingat, katakan kamu ada banyak-banyak bacaan CA kamu confused, kamu just ambil sequence 3 CA yang pertama, kamu masukkan dalam equation tu. So minus 3 CA0 plus 4 CA1 minus CA2 divided by 2 delta T. So delta T itu adalah gap time of which you take your reading. So katakan kamu ambil setiap 5 minit. Katakan minit 0, minit 5, minit 10, minit 15. So gap dia 5 minit kan. So delta T itu 5. Then multiply with 2. So let's say your reading you take every 10 minutes. Minute 10, 20, 30, 40. So gap dia setiap masa, senggat masa dia adalah 10 minit. So delta T become 10. So that depends. Sebab tu penting for this method, consistency bacaan tu kena ambil pada time yang consistent. Either every 10 minutes, every 20 minutes, every 10 minutes, every 5 minutes, regardless. Gap time tu is depending again on how fast is the reaction. Kalau reaction tu sangat cepat, kamu kena ambil pada senggat masa yang pendek, katakan every 1 minute. But if the reaction is slow, you can make it at every 10 minutes, depending. Tetapi dia mesti konsisten. Kalau kamu nak ambil setiap 10 minit, kena setiap 10 minit. Kamu tak boleh tiba-tiba setiap 10 minit, kejap kan naik 5 minit, tak boleh. So you must be very consistent. If you say every 10 minutes, so your delta T will be 10 minutes. Okay, so then you get the very first dCA per dt. Okay, so let's say we try one example sebab it's always easier kalau kita guna example. Okay, so katakan data yang kita ada from experiment, okay, 0, minute 2.5, minute 5, minute 7.5. So katakanlah you assume ni tidak berapa cepat. So setiap 2 minit setengah dia dah ambil bacaan, dia tengok berapa kepekatan A. So naturally, initially dia start dengan 4 molar katakan. So pada minit 2.5 bila dia ambil sampel, dia check concentration dia become 2.89. Minute 5 dia take out sampel, check 2.25. Minute 7.5 dia check 41.45. So dia dah ada data ini dah. Okay, so then kita nak guna ni data eksperimen ni, again kita nak cari untuk dCA per dt dan kemudian ln minus dCA per dt. Kita tak boleh stop kat dCA per dt sebab again our y-axis data is ln minus dCA per dt. So you need that data baru you can plot the graph. Okay, so first to find the very first dCA per dt untuk point pertama tu je. Okay, so dCA per dt equals to, so kamu just ingat kamu ambil tiga kepekatan pertama. The first three are concentration. That's why you get negative 3 multiplied with 4 plus 4 multiplied with 2.89 minus 2.25. So kita ambil je 3 first, the first three concentrations you arrange and then divide by 2 delta T. So the 2 is memang formula dia. Delta T kamu kena tengok sendiri. Dalam data ni I collect sample every 2.5 minute. That's why my delta T 2.5. So now you get your dCA per dt as negative 0.54. So sekarang kita dah dapat dCA per dt daripada formula negative 0.54. Tapi tak habis lagi sebab my y-axis data is ln minus dCA per dt. Maksudnya kita kena buat ln minus 0.54 ataupun in simple word ln positif 0.54 sebab negatif jadi positif, kita lonkan positif 0.54, you get actually negative 0.62. So this part yang penting lah, kamu kena be very careful when you do calculation sebab nombor dia negatif. Tapi kita kena negatifkan sekali, jadi positif. Jadi kita lonkan nilai tu dapat pula negatif. So that's mathematics lah. Okay, so done. So miss, you have obtained the very first y-axis data. So you can see this is tedious sebab nak plot graph tu pun kena ada formula. Dan nak kira tu pun baru dapat satu je data y-axis. Kita ada lagi 3 data y-axis, y-axis yang kita belum kira. Okay, so next one, we want to calculate for the 2 point yang di antara initial dengan last, kita ada 2 interior point. Okay, kita nak cari untuk the second data and the third data, berapa dia punya dCA per dt. So kedua-dua ni berada di antara initial dengan last. So kita akan guna interior point formula. Okay, mungkin kamu terfikir formula sama, nilai dia sama ke? Nilai dia tak sama walaupun you are using the same formula because you will use different concentration punya sequence. Okay, so itu yang part yang Abid memeningkan untuk interior point. Kamu akan menggunakan kombinasi kepekatan yang berbeza bergantung kepada kedudukan data mana yang kamu telah kira. Okay, maksudnya, okay, katakan you're calculating for this yellow box for the second data in the graph. Okay, for the second, dalam graph. The second data in the table, kita nak cari dCA per dt dia. So for this second data in the table, the dCA per dt at T1 akan sama dengan you take the concentration after the reading, which is Ca2, you minus with concentration before the reading, which is Ca0. So maksudnya, dia akan menjadi Ca2 minus Ca0. Okay, so again I repeat. Untuk mendapatkan dCA per dt untuk T1, okay, yang kotak kuning ni, kamu kena ambil kepekatan selepasnya after Ca2 minus the concentration before the reading, Ca0, divided by, again, same, 2 delta T. Okay, now, let's go to the third point ataupun the third reading. Kita nak mencari dCA per dt dia. So, dia akan menjadi dCA per dt untuk T2 lah, kan? The third point. So, it become equals to, again, take the concentration after Ca3 minus concentration before Ca1. So it becomes Ca3 minus Ca1 per 2 delta T. So you can see although I'm using the same formula, but the answer will not be the same because I'm taking the different sequence of concentration depending on data mana yang kamu tengah kira DCA per DT dia. Okay, so let's see this slide. Memang slide nampak kompleks kan, tapi saya explain in detail how. Okay, so tadi yang kotak pertama ni kita dah kira tadi. Kotak pertama kita kira guna initial point. Okay, so kita nak kira untuk kotak kedua, kotak ketiga. Hanya kotak kedua, kotak ketiga sebab in this case ada 4 saja data. So 1 initial, 1 last, 2 interior point. Okay, so katakan for the first interior point, which is the second reading, okay, second reading yang kotak kuning ni, maka DCA per DT for the T1 equals to concentration after 2.25 minus concentration before 4 divided by 2 delta T. Again, delta T 2.5. We are taking our data at every 2.5 minute. So 2 times 2.5, you get negative 0.35. However, similarly, we cannot just directly use because our y-axis data is ln negative DCA per DT. What we have is DCA per DT. So you have to do ln minus 0.35. So you will get negative 1.05. So now you have obtained the second data in your table for your y-axis. So then we go to the next one, third point. Okay, so third point or the third reading in the table. So the third reading become DCA per DT equals to, again, take the concentration after 1.45 minus the concentration before 2.89 divided by 2 delta T, again 2.5. You will get your DCA per DT for T2 as negative 0.29. So kamu nampak kan? Formula sama, tapi saya guna sequence concentration yang berlainan. So that's why nilai DCA per DT itu takkan sama sebab dia bergantung kepada bacaan kedua ke bacaan ketiga. Sebab kita ambil kepekatan yang sequence yang berlainan. Tetapi dia mesti sequence kepekatan selepas tolak kepekatan sebelum. Okay. Then you get negative 1.24. So now you have already obtained the two interior point punya ln minus DCA per DT. Done. So imagine as I told you, method ni eksperimen senang, pengiraan dia susah. Okay, tapi kalau, but of course you will use software, you will key in formula. It's not that menyusahkan juga lah. Manually, yes. Manually kamu kena buat banyak pengiraan sebenarnya. Okay, the very last one, untuk mencari the very last negative DCA per DT. So imagine kalau kamu ada katakan 6 ke 10 data ke, okay, data pertama initial point, data kedua sampai 9 interior point formula. The very last one, paling bawah, bacaan paling last tu, kita nak cari the DCA per DT, you will use the last point formula. So dia macam sama dengan initial point di mana you have to use 3 concentration. Initial point tadi kita akan guna 3 kepekatan yang paling pertama, yang paling atas. Untuk last point, we will use the bottom 3 concentration in your reading or in your table. So in this case, dia akan menjadi DCA per DT for T3, sebab our last point is T3. Untuk T3 equals to, tengok 3 kepekatan paling bawah. So become CA1 minus 4CA2 plus 3CA3 divided by 2 delta T. So kalau tadi initial point, 3 kepekatan teratas, follow je sequence dia. Last point, take the 3 bottom concentration. 3 kepekatan terbawah, ikut sequence dia, you will get your DCA per DT at T3. Okay, so let me give you an example of calculation. Okay, so you want to calculate the very last DCA per DT. So kamu tengok dulu 3 kepekatan terbawah. So you just substitute, follow the sequence. So become 2.89 minus times 2.25 plus 3 times 1.45. So sekuen dia mesti 1 darab minus 4 kali CA2 plus 3 kali. Yang nombor tu adalah formula dia. So kita ikut, yang penting sequence concentration tu kita kena buat sequence yang betul and divided by 2 delta T. So again the delta T is 2.5. So you get your dCA per dt as negative 0.35 and your ln minus dCA per dt as negative 1.05. Yang penting dah dapat nilai dCA per dt tu, kamu kena negatifkan nilai dia. Kalau dia dah negatif, double negative become a positive and then you lnkan the value. And the dCA per dt tak semestinya sentiasa akan negatif. Dia boleh jadi positif juga, depends lah. Okay, in this case dia dah negatif. Okay, so that sometimes can become the confusion. Right. Then next, okay. So that you have done all the calculation. Tadi kita buat, kita kira tu tak habis lagi sebab kita kena plot the graph. So imagine tadi kita ada 4 data kan. Okay, 4 data, kita ada data paksi X, data paksi Y. You plot the graph. Okay, daripada graph, Excel will give you the gradient. Your gradient, kalau kamu tengok equation, your gradient is your M, your slope. Your slope equals to alpha. Okay, straightforward lah. Katakan kamu dapat Excel kata gradient kamu 1.4. So you round up, dia jadi first order. Katakan kamu dapat Excel kata gradient kamu 1.8. Kamu round up jadi second order. Okay, so then next, K. So from the equation, ln K equals to your y-intercept. So katakan pintasan Y, Excel kata 4. So ln K sama dengan 4. Hence, K sama dengan exponential 4. So kamu ingat ln K sama dengan 4. K sama dengan exponential 4. So you get your ln K value. Okay, so this is, let's go for one example for us to better understand. Okay, kalau kamu tengok, saya guna data yang hampir sama, tapi data yang saya guna untuk contoh tadi, saya guna hanya untuk 4 yang pertama, saya tambah lagi 2 data bawah. So kamu nak imagine, biasanya 4 data is not so accurate. Okay, normally we go to 6 to 8. The more data, the better it is. Okay, ataupun the best one is you record until the concentration becomes 0. Means dah tak ada A langsung dalam kamu punya reactor. That will be the most accurate one. Okay, so from this data, okay, I want to find alpha, I want to find K and alpha using differential method. Okay, so first thing, okay, alright, kalau katakan you are given this question, or you have this set of data, you want to find alpha and K. So first step, find first the equation. Sebab kamu kena tahu dulu equation mana, because from the equation, then you will know what you need to find first for y-axis and x-axis. So kalau kamu tak tahu equation dia, kamu tak tahu apa data yang diperlukan untuk paksi Y dan data diperlukan untuk paksi X. So kalau differential method, kamu tahu data paksi Y mesti ln minus dCA per dt, data paksi X mesti ln CA. Selagi you don't have these two data, you can never plot the point sebab point dalam graph memerlukan kedua-dua paksi ni punya data. Tak ada data ni ataupun data salah, definitely method pun salah, jawapan pun salah. Okay, so kita start first dengan x-axis sebab data x-axis ni senang. Daripada data eksperimen, kita tahu x-axis adalah ln CA. So CA yang saya ada ni, saya lnkan sahaja. So ln 4, 1.39, ln 2.89, 1.06, so on and so forth. So kamu bayangkan setiap point kamu tu, data paksi X dah settle. Very simple. Okay, so since you use ln, the data may be negative or positive. So kalau kamu dapat negatif, tak menghairankan. Kamu dapat positif tu, tak menghairankan. As long as you calculate or you place the calculator accurately. Okay, so the problem is data paksi Y. Sebab data paksi Y adalah ln minus dCA per dt. So sebelum kita nak mendapatkan the X ada Y-axis data, kita kena satu kolom specifically untuk dCA per dt dulu. Sebab formula beri kita dCA per dt. So from the DCA per dt, baru saya boleh dapat only I can get for the ln minus DCA per dt. Okay, so here you can see I have 6 data, 6 reading, 1 initial point, 4 interior point, 1 final point ataupun 1 last point, sorry. Okay, so the very first initial point, okay, nak guna formula dia, ingat je, equals to negative 3, di mana nombor dia negative 3, 4, negative 1. So negative 3, take the first concentration, 4 multiply by 4, plus 4 multiply with the second concentration, 2.89, minus third concentration, negative 2.25, divided by 2 delta T, 2 times 2.5. So you will get negative 0.54 for your DCA per dt, and therefore your ln minus DCA per dt as negative 0.62. Okay, so that's the first one that you get. Okay, so just satu je. Okay, again. Delta T dia so happen masih sama. I'm taking my reading at every 2.5 minute. That's why your delta T 2.5. Okay, so next one is kita nak buat untuk the 4 initial point. So kita ada 4 initial point yang kita kena kira. Okay, so kita kena tengok betul-betul. Okay, katakan kita nak kira for the second data, second row. Okay, second row, maka DCA per dt sama dengan second row ni. Kamu ambil kepekatan selepas dia 2.25, you minus the concentration before it, 4. So 2.25 minus 4 divided by 2 delta T, 2 times 2.5. The third data, the third row, DCA per dt equals to concentration after 1.45 minus concentration before 2.89 divided by 2 delta T. The fourth point ataupun the fourth row will become DCA per dt equals to 1 minus 2.25 divided by 2 delta T, and so on until you get the fourth point. So you can see here, again yang penting, what we get from formula is just DCA per dt. You have to negativekan the value and then you lnkan the negative value. Then only you obtain the y-axis data. And lastly, the last point is to calculate the very last DCA per dt, of which you will then see you have to choose 3 concentration in sequence. Okay, the 3 concentration is the very last 3 concentration. That's why jadi formula dia DCA per dt equals to 1.45 minus 4 times 1 plus 3 times 0.65. The last 3 point. Then divide again by 2 delta T. You will get negative 0.12, which is your DCA per dt. And then minus the value, negativekan the value. If it's already negative, it become a positive. And then you lnkan the value, then only you get your y-axis data. So you can see you have to do 6 different calculations just to get the y-axis data first. So then you gather back, make sure you have both data. Kamu tahu kalau kita nak plot Excel, you need y-axis data, x-axis data. Okay, so when you have this data, then you plot the graph. This is example of the graph that I plot using Excel. Okay, dia definitely mesti akan dapat straight line sebab again kita guna linear formula. So dapat linear formula, line tu akan menjadi point tu, you can draw a straight line across it. And then don't forget, aim dia nak cari K, nak cari alpha. So from equation, okay, alpha equals to your gradient. Okay, so daripada gradient kamu kira, nah ni saya tunjuk ni manual calculation. I use the formula lah kan. Tapi kalau Excel terus dapat, you will get the gradient 0.8. Don't forget, round up to the integer, nearest integer, so it become 1. Ataupun we can say first order. Ataupun means it is the reaction is first order with respect to A. So we can write it as minus RA equals to KCA. Then next one, from the equation, ln K equals to y-intercept. So from the graph, the y-intercept is negative 1.79. Okay, from Excel. Again, kalau macam tengok manual ni memang tak dapat tengok. Kita kena guna Excel. Or if you are using graph, you will plot the graph, you can get it lah from the graph. Okay, so the ln K equals to negative 1.79. Hence, K equals to exponent 1.79. So, exponent 1.79, you get, exponent negative 1.79. Okay, tengok kadang saya pun lupa tanda negatif. You get your K 0.167. So, again, the unit for K, you have to understand that the unit depends on the order. This is a first order reaction. Kalau first order reaction, the K unit is the dimension of the unit, the dimension of K is per time. Okay, so time tu unit dia kamu kena tengok dalam contoh ni. Time dia dalam bentuk minit. In the experiment, we record the time in the form of minute. So, just dia jadi unit K tu per minute. So, let's say kalau kamu record per hour, jadilah per hour. So, kamu kena ingat, okay, dalam chapter 2, saya touch about it. Chapter 3, the unit of K depending on the order. Zero order, concentration per time. First order, per time. Second order, 1 per concentration time. So, unit dia betul-betul bergantung kepada reaction order yang kamu dah dapat from the answer. Okay. So, we are already done with half-life method, differential method. So, you can see now the pro and cons of half-life method, the pro and cons of differential method. So, we are left with another two more method. Integral yang a little bit long. Initial rate is very straightforward. Okay. Integral method. Okay, integral method ni of course lah. Kejap. Alright. Okay, integral method ni of course lah. Dan nama pun integral method. Therefore, kita akan guna integral equation. Okay, so now let's discuss the pro and cons. Sebab kadang-kadang kita belajar banyak method. Kita kena tahu apakah kelebihan, kekurangan, and it depends on, if you ask me mana method lebih bagus, actually it depends on your scenario. You have different types of scenario. Okay, so kalau you ask me about differential method, half-life method, the pro and cons I already discussed with you. Half-life method, tedious. Kamu kena run a few runs. But calculation dia more easier. Okay, sebab equation dia tak susah sangat. Differential method, satu run saja dah dapat data. Tetapi kamu nampak pada pengiraan dia disusahkan sebab equation dia kompleks. Kamu kena side calculation dulu, dapatkan data paksi Y, data paksi X, baru boleh plot graph. Okay. However, kedua-dua method ni, salah satu lagi kelebihan dia, which both of it share, differential method and half-life method. Method ni adalah, if you have, atau you, kalau kamu ada entirely reaction yang baru, ataupun bila kamu alter or you modify the reaction. Contohnya kamu tukar reactant ke, ataupun kamu tukar mangkin ke. So, nilai K, nilai alpha ni mungkin berubah. And kamu katakan kamu tak tahu langsung daripada literature, tak ada sumber rujukan, tak ada maklumat. So, you have to find it yourself. So, differential method and half-life method will be a preferable method in that sense. Okay. The integral method pula, apa pro and cons dia? Okay. Pro dia, sama macam differential method, eksperimen dia senang. Hanya satu eksperimen, in fact, we collect the very same data. Meaning, saya prepare satu fresh solution that I know the initial concentration, I place it in a reactor, I record the concentration at a consistent time, every 5 minutes ke, every 10 minutes ke, depending. And from that data, I can already plot the graph. Okay, that is the pro. Okay, the cons dia pula adalah kalau kamu tadi belajar half-life method, differential method, satu equation sahaja. Regardless reaction order apa pun, regardless nilai K apa pun, satu equation je. Di integral method ni, masalah dia, setiap order yang berlainan, katakan zero order, first order, second order, Setiap order ni ada equation yang berlainan. Means kalau zero order, kamu kena plot graph mengikut equation equation zero order. Kalau first order, kamu dah kena plot pula plot yang berlainan. Sebab dia ada equation yang berlainan untuk first order. Kalau second order pun, kamu kena guna equation second order, kamu kena plot graph. So masalah dia adalah bila katakan you don't know the reaction order. So you have to do randomly tau. Katakan okay, kamu try zero order. Tengok boleh tak? Tak boleh. Okay, try first order. Oh tak boleh, second order. So it be very tedious because you are doing it blindly. Kamu tak sure. Sebab untuk method ni, apa yang kamu buat? Okay, katakan kamu dah experimental data, kamu plot zero order, kamu kena tengok plot kamu fulfill tak requirement untuk zero order. Kalau tak fulfill means reaction kamu tu bukan zero order. So kamu kena try pula first order. So again, first order ikut equation dia, kamu kena plot graph. Okay, kamu kena faham. This reaction, order dia is very specific. Means kalau reaction ni zero order, kamu tak boleh paksa dia jadi first order, second order. Kecuali kalau kamu tukar mangkit atau kamu tukar reactant. Kalau benda ni masih sama, it's the same reaction. Kalau dia zero order, macam mana pun dia masih zero order. Kalau dia first order pun sama. So katakan, kalau reaction kamu tu first order, okay, tapi kamu plot equation zero order, kamu punya plot tu takkan memenuhi plot zero order sebab dia bukan zero order. So the same, kalau reaction kamu first order, kamu plot ikut equation first order, kamu akan dapat plot yang sepatutnya dan kamu boleh verify dia adalah first order. So same as the second order. So as I told you, if you don't have any prior knowledge, kamu do blindly, you will do a lot of random trial and error. And you don't forget, not necessarily reaction kamu zero order, first order, second order. It can be third or fourth order. So you are doing this blindly by random. Okay, so integral method is only advisable if you have prior knowledge and you just want to confirm betul tak tindak balas saya reaction order seperti yang saya tahu. For example, katakan your reaction is a common one and from literature dia kata first order reaction. So you would like to just verify betul tak tindak balasan ini mengikut literature. So kamu hanya akan plot ikut first order punya equation, kamu plot, kamu verify, dia ada certain characteristic that I will teach you and you can see kalau dia mengikut characteristic tu, you can confirm, okay, correct, my reaction is first order. So terdapatlah order reaction dia. So then lepas tu, daripada equation tu, kita akan guna untuk kira K. So kamu kena ingat, regardless method apa pun, the one that we want, K and alpha. Just like integral method ni kita kena somewhat assumption atau somewhat prior information untuk kita dah agak reaction order dia, so kita just verify. Okay, so that's the pro and cons of integral method. However, same tujuan, nak cari K, nak cari alpha. Okay, so again kita kena tengok equation dia sebab saya kata tadi kita ada equation yang berlainan. Kenapa kita ada equation yang berlainan? Sebab, okay, so you can see the first initial equation macam differential sebab dia letak minus dCA per dt sama macam differential tadi equals to minus RA equals to KCA alpha. So tadi kalau differential method kita linearize equation ni terus. Tapi integral method kita dah ganti dulu alpha tu dengan 0, dengan 1, dengan 2 ataupun 3 ataupun 4 ataupun selamanya lain. Tapi in my lecture I only cover 0, 1 and 2 order. Bukannya sebab apa? Because the common reactions, the orders are usually from 0 to 2. Rarely third order, fourth order. Although I will not say tak mungkin, tak boleh juga. Ada juga reaction yang boleh jadi third order or fourth order. Okay, so now kita kena periksa one by one. Zero order punya equation, first order punya equation, second order punya equation. Means kita ada 3 equation yang kita kena examine. Okay, so let's say now reaction kita tu zero order. Kamu baca pada information, kamu baca daripada literature, reaction kamu ni dia kata most likely zero order. Kamu guna reaktor yang sama, kamu guna semua parameter sama. Kita assume semua parameter sama. You can likely assume dia adalah zero order. Okay, kalau zero order, so the equation become minus dCA per dt equals to minus RA equals to K. So technically K, CA power 0, 0 order. Tapi kamu tahu kalau CA power 0, dia macam 4 kuasa kosong, dia adalah 1. 5 kuasa kosong adalah 1. So 1 darab dengan K, sebab tu tinggal dengan K. So ni yang membezakan. Kalau integral method kita akan integrate dia. So we will now integrate the equation of minus dCA per dt equals to K. I will integrate both left and right hand side. And then I linearize again dalam bentuk y equals to mx plus c. Sebab saya masih nak plot graph. So saya dah integrate, saya linearize dalam bentuk y equals to mx plus c. Macam mana kita integrate tu? It's okay if you don't really understand. It's not necessary for you to understand as well. Sebab yang kita penting, kita kena faham equation. Dan macam mana kita nak plot graph pada equation dia. So when you linearize, you will get in the form of zero order sama dengan CA equals to minus KT plus CA naught. So again, masalah dia macam nak tahu mana satu data pak CY, data pak CX. So come back again to your experimental data. Data eksperimen adalah time versus CA. Kita tahu pada minit kosong berapa CA. Minit 5, minit 10, minit 15. So CA0, CA1, CA2, CA3. All these are still CA. So we know naturally on your left hand side, your CA becomes your y-axis data. So senanglah, tak payah ubah apa-apa. Data eksperimen tu, data CA tu automatic data part CY. Dah tak payah cari log, tak payah cari dCA per dt, tak cari apa-apa. Terus jadi data part CY. So pergi perhatian belah kanan. So on the right hand side, naturally your time T become your x-axis data. So again, senang. Terus saja guna data eksperimen, dah kita boleh plot graph. So ini advantage dia pula lah, di method integral. Kalau zero order, kamu dah tak payah buat apa-apa. Kamu terus je plot graph daripada experimental data. But don't forget, apa yang kita nak? Alpha dengan K, right? So daripada plot, gradient kamu akan sama dengan negative K. So your slope, your graph punya slope tu, graph kamu punya slope is your negative K and your y-intercept is your CA naught. Okay, so now this is important thing that you have to remember. Kan saya dah kata, only and only if reaction kamu zero order. Okay, hanya bila kalau reaction kamu memang betul zero order and you plot the graph of CA versus time as according to the equation. So katakan dalam kes ni kamu ada 4 bacaan, kita ada 4 point. Kamu plot CA versus time. Kalau reaction kamu zero order, your plot will have these 2 characteristic. Dia mesti memenuhi, fulfill these 2 characteristics. The first characteristics, dia mesti straight line. Mesti straight line lah. Dia tak boleh bengkok-bengkok pun tak boleh. Dia tak boleh parabolik, dia tak boleh hyperbolic, dia tak boleh. Dia mesti satu straight line. And the straight line must have a negative gradient. So kalau kamu plot graph kamu dan kamu dapat katakan straight line tapi kecurunan positif, maksudnya reaction kamu tu bukan zero order. Dia hanya akan dapat kecurunan negatif straight line kalau reaction kamu zero order. So kamu kena, itu dah keistimewaan, the brilliance of mathematics and chemical engineering. Hanya satu senario memenuhi keperluan matematik tu. Kalau kamu punya reaction tu tak memenuhi senario tu, matematik tu tak akan dapat apa yang kamu sepatutnya dapat. And the second characteristic also that you must fulfill, your plot will have a y-intercept. Maksud dia tak akan ada pintasan Y pada kosong. Kalau pintasan Y pada kosong, maksudnya reaction kamu bukan zero order. So you must fulfill these 2 requirements, then you can verify and confirm your reaction is zero order. Means alpha kamu kosong. Dan kamu dah verify tu, then you find your K. So your negative K equals to your gradient. So katakan, so naturally, K kamu tu positif lah sebab kecerunan dia kan negatif. So katakan kecerunan dia negatif 5. So negatif 5 sama dengan negatif K, maka K sama dengan 5. Okay, so your K will be still a positive value and don't forget unit dia akan jadi concentration per time. Dimension dia concentration per time. So contohnya mol per liter minit, kilomol per dm cube hour, so on and so forth. Okay, so done on zero order. Okay, so now let's go first order. So again, first order equation dah berubah. So maksudnya kamu kena tengok pula macam apa pula equation. Kalau kamu rasa tindak balas kamu tu first order, kamu kena plot graph ikut equation first order. So let's say you find from literature, they say your reaction very likely first order. So kamu nak plot graph first order. Kamu kena ingat equation dia dah berubah. So what is the equation? Okay, so we start again from the very beginning. So negative dCA per dt equals to minus RA equals to KCA. Tadi equals to K sebab CA power 0 is still 1. So darab dengan K, K. Tapi ni first order with respect to CA. Sebab tu jadi KCA. So same concept, kita integrate belah kiri, kita integrate belah kanan, kita rearrange balik dalam bentuk y equals to mx plus c. And kita dapat dalam bentuk ln CA0 per CA equals to KT. So same concept, mana satu y, mana satu x. So kita boleh tengok data eksperimen kita CA dan time. Tetapi from the equation, your y-axis data paksi y mesti ln CA0 per CA. So maksudnya data eksperimen kita tu, kamu kena tambah satu lagi kolom ataupun satu lagi baris untuk mencari data paksi y dia, which is ln CA0 per CA. So maksudnya katakan untuk kes pertama, data pertama, dia akan menjadi ln CA0 per CA0. So kamu tahu kan CA0 per CA0 mesti kosong. So ln dia akan menjadi kosong. So maknanya data paksi y yang pertama adalah kosong. Data paksi y yang kedua akan menjadi, kamu kena ambil CA1 kamu bahagi dengan CA0. Yang CA0 tu adalah concentration at minute 0. So kamu ambil CA1 bahagi dengan CA0. Lepas tu kamu ln kan, dapat data kedua. Data ketiga, kamu ambil CA2, kamu bagi again dengan CA0. CA0 rasa sama sebab CA0 tu adalah the fresh solution punya concentration. So let's say lah, CA0 5, CA1 4. So 4 bagi 5, ln kan data pertama. Data kedua, sorry. Data ketiga katakan daripada 5 molar jadi 4 molar jadi 3 molar. So 3 again bagi dengan 5 sebab CA0 dia masih 5. So ln kan you get the third reading. Let's say dia turun daripada 5, 4, 3, 2 molar. The last one katakan 2 molar. So again, 2 divided by 5, you ln kan, you get the fourth data in your plot. So then, apa pula data x-axis? X-axis data is time. So x-axis kamu tak payah buat apa-apa. Ambil je data eksperimen for the time. So now you have the combination. Setiap point tu kena data dua-dua paksi. Kamu dah ada, kamu plot graph dia. Okay, so then again, kena check karakteristik dia. So kamu dah dapat data 4 data tu. Yang penting data tu mesti data paksi yang betul, which is for y is ln CA0 per CA, for x mesti time. So you plot the point, alright, and then check dia punya characteristics. So again, if and only if your reaction is first order. So again, kalau reaction kamu bukan first order, kamu plot graph ni, plot kamu tu takkan memenuhi kedua-dua requirement dia. Dia hanya kalau data kamu memang first order, only you will fulfill these two requirement, which is first. Again, dia mesti straight line, but now the straight line is with a positive gradient. So if you did not get a straight line of a positive gradient, it means your reaction is not first order. So kamu kena try lah zero order, kamu kena try second order, tengok balik. Second requirement, dia mesti without y-intercept ataupun y-intercept kamu adalah pada kosong. So, if you plot the graph correctly, your plot fulfill these two requirements, then you can safely say your reaction is first order. Maksudnya minus RA betul lah sama dengan KCA. Dan bila kamu dah verify tu adalah betul, then kamu cari nilai K. So nilai K dia from the equation, K sama dengan gradient. So dah plot graph, dah confirm first order, find the gradient. The gradient is your K value. And for first order, the K value is per time. So katakan per minute, per hour, so on and so forth, depending on your experimental time punya unit. And last one for today, before we end, cukup-cukup pukul 11, hampir 10 minit lagi, is second order reaction. So kalau second order reaction, so minus dCA per dt equals to KCA power of 2. So again, only and only if kalau reaction kamu second order, so kamu dapat negatif dCA per dt sama dengan KCA power of 2. So integrate belah kiri, integrate belah kanan. So kita panggil integral method. So you get, again kita rearrange dalam bentuk y, persamaan linear y equals to mx plus c, you will get on your left hand side 1 per CA, which is your y-axis data. So again jangan lupa, data eksperimen X dengan CA. So data y-axis ni kamu kena apa? Kamu kena reciprocalkan dia. So katakan CA0 kamu 5, 1 per 5, data pertama. Katakan CA1 kamu 4, 1 per 4. Data kedua, so on and so forth. So y-axis dia 1 per CA, and from the equation, your x-axis is still your time. So x-axis tak payah buat apa-apa, terus ambil time. So kamu ada 4 point kan, 4 point tu di mana part CY dia 1 per CA, part CX dia adalah time. So you plot the graph. Okay, so again, graph dia when you plot, you have to fulfill again another 2 specific requirement. Ini kalau tak fulfill, kamu tak boleh kata dia adalah second order. Okay, so again, maybe I forget to explain macam mana kita tahu requirement tu. Okay, so I slip back to zero order. Okay, saya terlupa part tu. Macam mana kita nak tahu order dia kan? Okay, so sorry. Okay, kalau dia zero order, kamu tengok equation dia. So equation dia, kamu nampak yang dia punya M ni adalah negatif K. Maksudnya kecurunan dia mesti negatif. Sebab tu saya kata graf kamu kena ada kecurunan negatif. Okay, sebab memang equation dia ada negatif K. Negatif K itu adalah gradient dia. Sebab tu plot dia mesti straight line, kecurunan negatif. Kedua, kenapa saya kata mesti ada pintasan Y? Sebab kat belakang dia ada plus CA0. CA0 tu kan adalah pintasan Y. Sebab tu saya kata dia mesti ada pintasan Y. Okay, kalau first order, kenapa saya kata positive gradient tak ada pintasan Y? Sebab kamu tengok equation dia, K dia tu sama dengan M. So maknanya positive K. Sebab tu saya kata straight line dengan positive gradient. Kedua, kenapa saya kata tak ada pintasan Y? Kamu nampak kat belakang ni tak ada apa-apa kan? Terus equals to KT. Dia tak ada KT plus something. Means tak adalah pintasan Y. Sebab tu dalam graf kamu takkan ada pintasan Y. Sebab equation tu kata kalau kamu plot graf ni, data kamu memang data first order, data kamu tu, plot kamu tu takkan ada pintasan Y. So next one, second order. Hence, kamu tengok equation, kamu dah boleh agak apa dia punya requirement. Your plot will definitely have a straight line of positive gradient. Sebab K. K sama dengan M. So, positive gradient, straight line. Requirement pertama. Requirement kedua. Tengok kat belakang tu ada plus 1 per CA0. So, plus 1 per CA0 tu adalah kamu punya pintasan Y. So, your graph will have a Y-intercept. So, if and only if your reaction second order, your graph will show these things. Straight line with a positive gradient with a y-intercept. Kalau reaction kamu bukan second order, dia tak akan memenuhi keperluan ini. Okay. Then, once kamu dah verify alpha kamu adalah 2, then only from equation you can see your gradient is once more your value of K. So, I will just plot the graph. I will get the value of K from the gradient. So I can verify that this equation, this reaction is second order, and I can obtain the value of K from the gradient. Okay, so we are done with all the main method, and the last one, which I will go quite quick, is the last method, initial rate method. So this method, we will just learn the equation. Okay, we will just learn familiarize, but we will not go further, as this experiment dia inherit all the cons of other method. First, you have to run many experiment. Second, equation ni pun complex, so you will have to do a lot of experiment, dah memakan masa. Plotting the graph is also a problem. So this method is not really common as it involves a lot of work. Tetapi you must remember, reaction kamu tu kalau dia second order, kamu guna method mana pun masih second order. So it doesn't really, in that sense, method tu hanya cara kamu approach kepada problem tu, tetapi jawapan akhir dia masih sama. Okay, so method initial rate, okay, what do you do is, experimentally, kamu kena run few set of experiment di mana kamu menggunakan different CA0. So bayangkan kamu kena run, katakan 6 run, each run with a different initial concentration of A. So katakan 5 molar, second one you start with 8 molar, you start with 10 molar. So in comparison dengan method differential integral, sekali je prepare. Then from that run, okay, kamu akan determine initial rate of reaction, ataupun arti kata lain, we determine the rate reaction pada masa kosong. Then from that reading, so kamu akan dapat sekarang CA0, kamu akan dapat minus RA0. Kenapa minus RA0? Sebab kita measure pada minit kosong. From that to experimental data, again, kita akan guna equation linear ni, kita akan plot graph. Tapi graph dia akan menjadi in the form of ln minus RA0 melawan ln CA0. So data eksperimen tu, kamu plot graph. From the graph, you will get your alpha, which is your gradient, and your ln K, which is your y-intercept. Okay, so again, as I told you, the methods are different, can be different because of the equation, but ultimately reaction order dengan nilai K takkan berbeza sebab dia hanya method di mana how you want to approach the problem. Okay, so that's all. I'm done for chapter 5 today. Quite fast chapter. Chapter 5 is not difficult. Okay, so maybe next week I will have to do one class on Thursday for tutorial, a very brief tutorial, maybe on chapter 5, maybe 1 hour tutorial. And then Saturday as usual, I will finish up chapter 6. And then I need maybe another 2 more weeks of lecture lah, sebab lecture chapter 6 ada sikit pengiraan. 7, 8 is already very easy. It's a reading chapter. Okay, so that's all for today. I hope you have a good day. I will again